Today's objective is that we are going to find indefinite integrals using antiderivatives. Um, so our first example is the integral of 80x to the 79th plus 10x to the 4th minus x to the 3rd. And it's important to know about integrals, just like derivatives, that you can just take each term by itself. Each of these is going to be the integral using the backwards power rule, which means you keep the base, add 1 to the exponent, so this is going to be x to the 80th, and then take the coefficient and divide it by that exponent. So 80 divided by 80 is 1. I'm not going to write it. Plus, the next one, x to the 4 plus 1 is 5. 10 divided by 5 is 2. Minus 3 plus 1 is 4. And then the coefficient 1 divided by 4 is 1/4. All indefinite integrals, we put a plus c at the end because there could have been a constant that when derived disappeared. So this is our integral. You can check it, of course, by deriving what we got to make sure that it comes out to the same thing as what we started with. Next example, integral of sine is negative cosine, so therefore the integral of -3 sine of x is positive 3 cosine of x. This is just one that you have to memorize. The integral of cosine is sine, so therefore the integral of 7 cosine is 7 sine of x. And then we put a plus c. That's it. These are just ones that you need to know. The third problem, I'm going to rewrite it before I integrate in a way that might make a little more sense. So that first one, that 3 over x, might look like a polynomial type power rule one, but really this is 3 times 1 over x. So this is going to be a natural log integral. Plus x squared in the denominator can be written as 3x to the -2. And now this looks more like that first example. And the dx is still at the end. So the integral of 1 over x is natural log. So 3 natural log of the absolute value of x. And then let's see, x to the -2. -2 plus 1 is -1. And then 3 divided by -1 is -3. So this is minus 3x to the -1. I'm going to leave it like this, but you could write it differently with a plus c at the end. Our next couple of examples. First one, we've got integral of -18 e to the x. Well, that's easy because e is always the same with derivatives, so that goes for integrals too. So our integral is -18 e to the x. This one's going to be a little annoying, but it's not too bad. Still a power rule problem. -2/3 plus 1 is positive 1/3. So this is going to be x to the 1/3. And then when you take the coefficient of 1 and divide it by 1/3, instead of writing 1 over 1/3 like this, it reciprocates, and this becomes 3. So this is going to be plus 3x to the 1/3 plus 6 times, you probably have memorized this, or I recommend that you do. The integral of square root of x is 2/3 x to the 3/2 with a plus c. And I'll simplify this just a little bit. So we've got -18 e to the x plus 3x to the 1/3 plus, and then 6 times 2/3 is 4 x to the 3/2 plus c. Finally, in this section, we have a problem that we can't actually do the way that it's written. So there is no such thing as the product or quotient rule when it comes to integrals, so you just have to do something first. In this case, pretty clearly the thing we're going to do is distribute. So I'm not integrating yet, I'm just rewriting this. This is the integral of 3x cubed plus 11x squared dx. And now I can actually integrate this using the backwards power rule. So our integral is going to be 3/4 x to the 4th plus 11/3 x to the 3rd plus c. And that's it. So our objective today was that we were finding indefinite integrals using antiderivatives.